everyone,
to our beloved teachers and faculty. We are the Group 4 from MASINAG. And we are here to discuss
and explore
Charles Law.
For starters, let's discuss the proponent of Charles' law. And here we have Jacques Alexander César Charles.
He is a French mathematician that discovered the relationship of temperature and volume at constant pressure, which is known as Charles' law.
The concept of this law is simple. It only states that at a constant pressure and amount of gas, when the temperature increases, the volume of the gas will also increase. In simple terms, this law states that when the pressure and amount of gas is constant, the temperature and volume of the gas will be directly proportional.
In mathematical computation, we can express this as volume is directly proportional to temperature, or V over T is equal to K. We can also use V1 over T1 is equal to V2 over T2.
To better understand this, we can use a balloon for example. When a balloon with gas or air inside is placed in cold water, the balloon will decrease in volume. And when it is placed in boiling water, the volume of the balloon increases. Kagilupit. Sheesh! Napakaangas! Hey!
Next, we have the PhET simulation parts. Let's start with a container. Container is the part that holds and keeps the gas molecules inside.
A piston is the one that adjusts the container size in terms of its width. Select what gas property will be held constant.
This adjusts the temperature, heating or cooling the container that contains the gas molecules inside.
Pump gas molecules inside the container. Reads how hot or cold the gas molecules inside the container.
For this demonstration, we are using the PhET gas property simulation to illustrate Charles' law, which states that at constant pressure, the volume of a gas is directly proportional to its temperature. First, I'll add 15 gas molecules using the pump gas option so that we can see how they behave inside the container. Next, I'll select the pressure arrow above from the right panel, wherein this setting means that the simulation will keep pressure constant and the volume will change as we increase or decrease the temperature. And the piston here moves sideward, and we'll observe how its movement represents changes in the gas volume. Now, let's try to increase the temperature using the slider. But first, let's open this so that we can see how the volume increases or decreases. Now let's try to increase the temperature using the slider. As you can see, as the gas particles gain heat energy from the heat slider, they move faster and collide more forcefully with the walls of the container. You can also observe that the piston moves to the left, even though it's moving sideways. That movement means that the volume of the gas is increasing, wherein the pressure remains at constant because of the setting we chose earlier. So this shows that when temperature increases, the volume will also increase, which follows the Charles' law. Next is let's lower the temperature. As you can see, when the gas cools, the particles slow down and they collide with less force. As a result, the piston moves to the right, showing that the gas is contracting or that the volume decreases as temperature decreases. Since the pressure is still constant, this again demonstrates Charles' law. At constant pressure, volume is directly proportional to temperature. Giving a short summarization, even though the piston moves sideward in this simulation, it still represents the volume of the gas. And when the piston moves to the left, the gas expands, meaning the volume increases. And when it moves to the right, the gas container contracts, meaning the volume decreases. With the pressure kept constant, we can clearly see that increasing temperature increases volume and decreasing temperature decreases volume. This experiment successfully demonstrates that in Charles' law, while using the PhET gas property simulation, Charles' law statement is indeed directly proportional. As the volume increases, the temperature increases as well. And while the temperature decreases, the volume of the container decreases as well.
We are the group 4 from Empwerment. And we are here to discuss
And explore